reusability in machine learning. It is a short talk, so we're going to try and cover two things. We're going to set a bit of context around some of the challenges with machine learning. Everyone here probably in this conference has probably heard so many different things. I don't think we'll spend a lot of time on that. And then the second, we'll actually dive into an approach to reusability. Before we do that, let me just do a brief introduction of myself. Who am I? Nayur Khan. I work for a company called Quantum Black, which is part of McKinsey. For those that don't know, Quantum Black is the center of excellence for artificial intelligence within McKinsey. It came out of Formula One, which is why there's a picture of a Formula One car. I have a software engineering background, 20 odd years in the industry, working in various different verticals and organizations. I've run large-scale engineering teams, and now I help my clients scale AI. And what do I mean by scaling AI? I mean moving my clients from single-digit kind of pilots and into production to tens or hundreds of models running in production. And I'm fortunate to be able to do that in various different industries with clients all over the world. You could also find me on LinkedIn. Okay, so with that intro out the way, let's do a brief recap with some of the challenges of machine learning. Usually we find two different things. One, messy data, and it's interesting on this one. We won't have time to go into this, and I would love to have done a deep dive talk on this in itself. There's a lot of comments on Slack around this. Messy data causes a lot of problems, and there's ways of actually handling that. We're actually going to focus on the code aspect. And when I talk code, lots and lots of code. Code in notebooks, code in monolithic code bases, in hacky kind of scripts, all over the place. This kind of leads to general problems that we see with a lot of our practitioners. Data scientists have to learn lots of different tools, especially to get something to be high quality code that actually makes it into production and is maintainable. Everyone works in a different way. No matter who you speak to, they have got their own ways of working. It works on my machine is always the excuse we've always heard. You know, code doesn't run on another person's machine. Different levels of exposure to software engineering concepts. And general, the general trend, it takes a very long time to actually build something reliable that actually goes into production without having to rewrite it again and again and again. And I think some of the earlier talks talked about ways of handling the process. But we also find this scenario where we have several different teams within organizations sitting side by side, sometimes in the same offices or sometimes geographically dispersed. Combinations of data engineering and data science, along with some kind of product manager, writing lots of different these types of monolithic type code bases, notebooks, etc., etc. Now that leads to the general premise that there are lots of problems that come out of that. One, a huge amount of lack of reuse, which is going to be our focus, but lack of collaboration, even within the same team, or sharing of knowledge or sharing of libraries. The second, around duplication, like reinventing the wheel. I've seen this in teams that sit side by side, not just in different locations, but literally solving the same problem again and again. However, solving the same problem again and again, but doing it in an inconsistent way. And we talked earlier briefly about the messy data, which causes different problems. What is a source of data? What is a source of truth? Using different algorithms, leading to lack of trust in the eventual AI models that make it into production. That causes huge amounts of maintenance problems, especially if you have a kind of a very small team that are building these models, but then trying to hand it over to some kind of support team to kind of maintain and nurse it in production. And the final point, which is one that's close to my heart, but is the huge amount of tech debt that's left behind, with huge swathes of monolithic code. No one understands what's going on, how to reproduce these pipelines or these models, and how to maintain it. Okay, so with all of that context set, I'm going to now whiz a little bit through the reusability aspect. Like, is there a really simple way of looking at what this code is doing? And here I'm trying to illustrate, look, it connects to some data. It does some cleaning, joining, transforming, aggregating of that data. It's building features, it's building models and training models, and then there's some kind of visualization at the end. The overarching question I'm asking is, could we somehow package this up for some reuse? And I think we can. So let me just introduce you briefly to something called Kedro. So Kedro is an open source framework that we built at Quantum Black. Initially, we had this problem ourselves. we wanted, we noticed within our own teams, different teams were actually developing in different ways. And that was causing us problems in terms of maintainability. So we built Kedro to solve that problem. But then we realized it has a benefit for our clients, but also for the wider good. So hence why we built this framework for data scientists, for data engineers, for machine learning engineers, and we made it open source. And really trying to set a foundation of creating repeatable data science code and providing an easy way to transition from development to production without having to rewrite your code. And just borrowing and applying software engineering concepts to do this, but applying that to data science. Why I think we've covered this, but really there are lots of shortcomings of doing things with Jupyter. I've seen on the Slack channel, I've seen in various different threads and conversations, we're not trying to put notebooks into production. And the same thing, it's not really a good idea to do one-off scripts or monolithic type code bases. It becomes really difficult over time to actually get this right. Our focus is on creating maintainable data science code, applying those software engineering concepts such as modularity, separation of concerns, testability, and really driving into like reusable analytic code. There's also another benefit too, which I really want to touch on, which is around enhancing team collaboration. And this is not just within members within the same team, but also between different teams within the same organization, really trying to address some of the problems we talked about earlier. So briefly, where does Kedro sit in the ecosystem? So if I start on the extreme right, it does not try and solve deployment or pipelines or models or orchestration of that. There are other frameworks out there which are fantastic and good to look at. What it does do is the initial parts, especially if we're talking that code base around ingesting of data, cleaning, joining, wrangling type data, building engineering features, and training and validating and building models. So back to what we started earlier. We said there was here are some of those code bases are doing. They try to connect to data, they try to clean, transform, they try to build features, and they try to build models. Could we use Kedro? And there's a really nice feature within Kedro around something called reusable pipelines. Think of it such as Lego blocks. Is there a way to actually use Kedro and use these Lego blocks and have them used by different teams? So team one might be looking at some kind of sales data, cleaning, transforming, building features, and then eventually building a model. Team two might say, look, I want to use some of those building blocks off the shelf, these Lego blocks, but maybe I want to use some marketing data. Maybe I want to join those two together and do something different, but then use the other standard stuff, including the models itself. Really trying to address the lack of reuse we talked about earlier, the duplication, this inconsistency, make maintenance far more easier and reduce tech debt. Now, this is a really short talk, and we're not going to get time to drive into each one of these concepts, but I'll touch a little bit on some of the software engineering concepts of using Kedro and designing, well-maintained Kedro pipelines. And here is where I go back to some of the software engineering principles. And there are lots and lots of material on this. I wish we could have done a longer talk on this, but I'll rattle through this and I'll put some links up on the Slack channel afterwards. So the one, don't repeat yourself, is just a general thing. Tremendous amounts of copy pasta code I've seen over my years. Of just remove, don't do that. It causes lots of problems, especially around maintenance and tech debt. The second is around solid principles. If you've not come across this, Robert C. Martin has a fantastic book on this. But really, single responsibility is a fantastic principle. Each class, each function has a single responsibility and only one reason to change. The open-close principle, Liskov, interface segregation, and dependency inversion. And then the final, which I really love, is Yagni. It sounds like a great idea. You write some code and you put it in the code base, but you're never going to use it. It's just an idea. And what you've just added is huge amount of technical debt and confusion down the road for maintenance. So given that you have all these Lego blocks and now you focused on building very reusable type pipelines, is there a way to actually discover this? And this is really where you're going to have to pay a little bit of attention to, like, how do my teams discover what Lego blocks exist, like these reusable pipelines? So one, I would recommend looking at some kind of knowledge repo or wiki. We internally at Quantum Black, we have our own product called Bricks that we use internally, and we've got 4,000 of our own practitioners that use that. Airbnb has one, an open source one, which is also fantastic, called Knowledge Repo, surprisingly enough. I would check that out. The other thing also sharing source code via Git and via some kind of snippets and put it into Git. And then finally, sharing the components via some kind of artifactory or repository internally, so you could do simple pip install. So just going to quickly recap this and end this. I think we're going to hit our time soon. What did we cover? We covered the challenge of machine learning. So briefly, we talked about lack of reuse, duplication, inconsistency, maintenance, and tech debt. And then we talked about an approach to reusability. I introduced Kedro, which is an open source framework that we at Quantum Black use, and a lot of our clients and out there use that too. Kedro has a fantastic part of it called reusable pipeline, which allows you to kind of break up these different concerns within inside the code base and treat them as Lego blocks, and really focus on having a way of actually just assembling pipelines together and models. Focus on good software engineering practices and principles to actually build those pipelines. And I mentioned Dry, Solid, Yagni. There are many others. I do encourage looking at that. And then fourth, have a sense of kind of discoverability, have some kind of tool in place so you could actually discover what Lego blocks have been built already inside your organization that you can leverage. I'll put the links in the Slack channel for Kedro. There's also a demo. I'll put the link in the Slack channel, which just shows the nice visualization that Kedro can do in terms of these complex pipelines. And finally, before handing it over back to Demetrius, I'll ask just a general question. What is the end goal here? And again, on the Slack channel, there's lots of activity talking about this. Is it to build a one-off on the left-hand side type of insight, type of model? You've handcrafted it. You've spent a lot of time on it, and it serves a purpose. It kind of works. Or does your organization that you work in want to really scale this out and really try to industrialize this whole process and try and really build reusable pipelines? I go back to the clients I work with. They really are trying to not just do one model. They've gone past the experimentation stage. They really want to do multiple tens, hundreds, maybe even thousands of models in production. And that really needs to a good software engineering practices and processes really need to be put in place. And with that, I will hand back to Demetrius.